Hello everyone, welcome back to my YouTube channel. Today we are going to discuss block diagram representation of a system. As you can see, we all know what a system is. Consider an electronic system, for example an RC coupled amplifier. There are many components like transistor, capacitor, resistor, etc. Each of these components performs different functions. That is, each of these components make some changes in the input signal. So here what we are going to do is we are going to learn block diagram representation. It is basically representing a system, an actual system in terms of a transfer function. So in order to do that, I will say it is a pictorial representation of a complex system in a simple manner. So I'm first of all I'm drawing a symbol system. So as we all know, a system has an input and an output. So I'm considering a system with an input and an output. Let the input be R of t and the output be C of t. Then the system will do some functions and I call that as transfer functions. Okay, transfer function. I'm calling it as transfer function. So what happens is I'm giving an input, I'm getting an output, and some things are happening within the system, and I'm representing it as transfer function. And in terms of Laplace terms, I'm representing the system as R of s, C of s. The input is R of s and the output is C of s, and the transfer function, the function that is happening inside, I'm representing it as G of s. Okay, so this is how you represent a system in simply block diagram representation. Okay, so next what we'll learn is we'll learn some additional things that we use to represent a system in a block diagram. As a block diagram, while we are representing, we use some kind of addition and subtraction methods. So what I'm using is summing point. I'm telling you about summing point. Summing point is basically nothing but just something to add two signals. In order to add or subtract two signals, what we use in a block diagram is we use summing block, and it is represented like a circle with a cross on the inside. And I could either write add. If I am adding two signals, I could write add. So here I am writing R1 of t and R2 of t, and I am giving them as input to the summing block. It means that the output from the summing block will be R1 of t plus R2 of t. Okay, and similarly I could also do subtraction with the same block. So in similar way I could do subtraction. So I'm writing minus, I'm writing plus. So R1 of S, I'm representing in Laplace form. So R1 of S, R2 of S, this will be, the output of the system will be R1 of S minus R2 of S. So in order to represent a system as a block diagram, we have some parameters that we can be used in that system. That is, one of them is summing point. We can use a summing point to add or subtract any signals that you want to. Next is a takeoff point. Takeoff point is basically very simple. It's just a point where you take the value. If you want two values from one point, you take 2 points. That's like a branch. Okay, takeoff point. A takeoff point can be represented by, if I'm considering a system, and the takeoff point can be represented by a point where I can take out two values. Like if I'm giving an input R1, then I'll get the value here as R1 into G of S. That will come later. We'll come to it later. Okay, we'll get that particular value here, and this same value will go through this way as well as this way. That's what a takeoff point indicates. It helps in forming parallel blocks basically. So there is takeoff points, summing points, and also we have learned about the basic block diagram representation. Now we'll move on to block diagram of a closed loop system. So I'm writing block diagram of a closed loop system. It is basically a derivation which is very important. The equation of this derivation, The final equation is very important. It is mainly used for block diagram reduction. One of the main equation that is used for reduction is from this derivation. So I'm gonna start writing. So how will a closed loop look like? Yeah, it will obviously have a feedback. That is, the output of the system will be fed back to the input in order to make it a closed loop system. So what I'm gonna do is I'm gonna draw the basic diagram that I have drawn earlier, but I'm making some differences. That is, I'm adding a summing block over here, and I'm adding the what I had written earlier. Okay, same block, that is the transfer function block. Okay, and I'm giving input as r of s. I'm taking output as c of s. Okay, this is what we have drawn earlier, but I have added a summing block here. Now what I'm going to do is I'm going to take a portion of the output, that is the c of s. I'm taking it from here. I'm taking a portion of the output and I'm going to fed it back to the input. But how am I going to do it? I'm going to represent it as h of s. Some function is happening. I'm taking the output and doing some function. It could be measuring that signal. It could be like taking difference of that signal. Whatever function it may be, I'm representing as h of s. And I'm giving it back to the input. So this is how you represent a closed loop system. And the next thing I'm gonna do is, what I'm gonna show you is, I am letting this backward gain be b of s. I'm letting this backward gain to be b of s. So what signal that will be flowing to the summing block is b of s, and that will be equal to, I'm writing b of s is equal to simply the output into this will give you b of s. That's the signal that's flowing back to the input. So c of s into h of s is b of s. Okay, we have done that. Now what we'll do is we'll do another signal. That is, first we have given an input to a system and we have gotten an output. What we are going to do is we are going to give a feedback. That is, we will be feeding a portion of the output signal to the input signal, and it could be like a sensor response. Like if I'm taking the value from the output and I'm comparing it with some reference value, if there is any change in the value, if there is an error, I'll correct it. That's what I'm going to do. So what will be left, that is, here if I'm, in case if I'm doing like I'm inputting r of s and I'm subtracting this difference, I'm taking the difference, then the value that will be left will be an error signal. Okay, the value that will be left will be an error signal. So this is basically what we learned here. Okay, now I'm gonna teach you the basic equations. In order to find the transfer function of a system, overall transfer function of a system, transfer function is basically the output by input. I would say output by input. So here the output signal is c of s and the input is obviously r of s. So our transfer function will be c of s by r of s. And our loop transfer function will be I'm writing the loop transfer function. Loop transfer function will be, it is a loop, no? It is coming from c of s, it's going to here. So I'm writing it as c of s into h of s. Okay, that is our loop. I'm so sorry, it's my mistake. This is not how you write the loop transfer function. I'll tell you how you write the loop transfer function. It's basically very simple. Just follow the arrow. First of all, it's a loop, right? So I'm going from one point. I'm going from the summing point. I'm going straight and it goes right down and it goes like this. This is how this loop goes. So when I'm following the arrow, I noticed that there are only two gains. That is g of s and h of s in that given loop. So it will be g of s into h of s. Okay. Now we'll move on to our output. What will our output be? Basically, our output is nothing else other than C of S, right? Our output is C of S, and that will be equal to, in block diagram reduction, what we does is, if there are two blocks like series blocks G1 and G2, how will we write this? We'll write this as G1 G2. So similarly here there is signal E of S and a gain G of S. So what will be the output C of S? It will be obviously E of S into G of S. Okay, so we have written the output. Okay, now we will move on to E of S. E of S, the error signal that I had said earlier. Look at this summing block. R of S is plus and B of S is minus, right? So error signal is nothing but, which is equal to R of S minus B of S. So R of S minus B of S. And from the above equation we have written what B of S is. I am taking it as 1 and I am putting that value here. And it will be R of S minus B of S is C of S into H of S. Okay, now that I have written what E of S is, now I will move on to C of S. We have written C of S here, and here there is E of S term, right? So we will put this value into this C of S. So it will be C of S is equal to R of S minus C of S H of S into G of S. So on solving this, what will we get? Just G of S R of S minus G of S C of S H of S. Okay. Now when I look into this particular equation, I could see that here is C of S and here is also one C of S. So what I'm going to do is I'm going to take this whole thing to the opposite side, and that will be C of S plus. Since this is minus, it will be plus on the other side. So C of S plus G of S H of S C of S equal to G of S R of S. On solving it, I am taking C of S outside as common, 1 plus G of S H of S. And here it will be G of S and R of S. Okay. We have seen what the overall transfer function is. It is nothing other than C of S by R of S. In this equation, we have the C of S and R of S. So in order to find the transfer function, what we are going to do is we take transfer function, which is equal to C of S, that's the output, by the input R of S. So I am taking this R of S to the opposite side and this equation to the opposite side. Okay, while doing that, I'll get G of S by 1 plus G of S H of S. Okay. The last equation that we have gotten is the equation for the closed loop system. What equation? I'm going to ask you, what equation is it? It is none other than the transfer function. Okay. So we have derived the transfer function of a closed loop system, and that's all for today. Thank you so much for watching. In the next class, we will be dealing with some properties or how to solve the transfer function, the block diagram reduction, how to reduce a block diagram. A block diagram is actually a very huge set of blocks, and we have to reduce it and make it onto single block. That is what we call block diagram reduction. We'll be dealing with block diagram reduction in our next class. Block diagram reduction is basically reduction. It means that there will be lots of blocks, like one block, second block, summing block, there will be summing block, and feedback blocks also. There will be feedback blocks, just take off points, everything will be there, and we will be reducing a complex block into a simple block with an input R of S and an output C of S. We will reduce it into a single block. That is what we call block diagram reduction. In the next class, we will be dealing with some tricks on solving a block diagram and reducing it to a simple diagram. And on the next video, I will try to put some questions. It is like a lengthy problem. You have to draw lots of diagram in order to solve that. So if you are understood, please like and subscribe to my channel, and thank you so much for watching.